Welcome to tonight's journey. This is a quiet space where science becomes a companion to sleep, where the silent movements of the earth are told in a slow rhythm, allowing you to both listen and relax your body. Tonight, we will explore the secrets hidden beneath the seemingly motionless crust of our planet, a world that never stops transforming, silent yet full of power, that has created mountains, oceans, and even the very continent you are standing on. If you wish to continue accompanying these magical scientific journeys, don't forget to subscribe and stay until the end of the video. Who knows, the endless vibrations beneath our feet might just be the key to guiding you into the deepest sleep tonight. When we look down at the ground beneath our feet, it's easy to believe it is permanently stable. The floor doesn't shake, the path doesn't shift, and even the asphalt roads lie still as if they were fastened to the earth. But that is only an illusion. The truth beneath is a vibrant world, always in motion, and it is precisely these shifts that have shaped both natural history and human civilization. Majestic mountain ranges, vast oceans, and even the smallest islands in the sea are the results of a silent dance our planet has performed for billions of years: plate tectonics. It is hard to imagine that the surface of the Earth, which at first glance seems like a massive, unchanging block of rock, is in fact like a mosaic of gigantic fragments constantly colliding and drifting apart. These tectonic plates are enormous in size, each spanning thousands of kilometers, and all of them move at a pace slower than the growth of your fingernails. Yet over millions or even hundreds of millions of years, those tiny shifts accumulate into monumental transformations. Oceans open, continents split, mountains rise, and then are eroded away, creating an endless cycle. What makes plate tectonics so extraordinary is not only its movement, but also the way it keeps the Earth alive. If the planet's crust were just one solid, seamless block of rock, Earth would likely have cooled long ago, becoming a silent world like Mars or the Moon. But thanks to its division into tectonic plates, energy from deep within the Earth finds a way to escape, released through volcanoes, ocean trenches, and newly formed mountain ranges. This is the hidden engine that sustains climate, geological cycles, and even the conditions necessary for life. The fascinating thing is that this idea was not always obvious. For centuries, humans believed that continents stood still, unchanging. Mountains were thought to be the work of divine hands or ancient catastrophes. No one imagined that the earth itself was moving beneath their feet. It wasn't until the early 20th century that a scientist named Alfred Wegener dared to ask, could the continents once have been joined together, only to slowly drift apart like giant torn fragments? Looking at the world map, Wegener noticed something few had paid attention to. The eastern coast of South America fit almost perfectly with the western coast of Africa. The similarity went beyond shape. He also found identical fossils on continents separated by thousands of kilometers, as well as traces of mountain ranges that once stretched across lands now divided. To him, this could not be mere coincidence. It was evidence of a larger picture. The continents had once been united and then gradually drifted apart. Even so, Wegener's idea met fierce opposition. At the time, science had not yet found a mechanism powerful enough to move an entire continent. His colleagues argued that his view lacked foundation and even ridiculed him. But that is often how the history of science unfolds. A bold idea is dismissed at first, slowly proven by undeniable evidence. And so it was. Only a few decades later, research on the ocean floor and Earth's magnetic fields confirmed that Wegener was right. The continents really are drifting. This discovery completely changed the way we view our planet. Instead of a static world, Earth became a living body, its crust moving endlessly like stretching skin. Plates colliding form the towering Himalayas, separating create rift valleys in Africa, and sliding past each other form fault lines like the San Andreas in California. Each earthquake that shakes or each volcano that erupts is not just a disaster. It is a reminder that the Earth is always in motion. More importantly, this movement has played a decisive role in the existence of life. The plate tectonic cycle recycles the crust, carrying carbon from the atmosphere into the Earth through subduction, then releasing it back through volcanoes. This very mechanism balances the climate, preventing Earth from becoming too hot or too cold. It could be said that without plate tectonics, This planet could never have maintained the stability necessary for life to evolve over billions of years. This also leads us to a philosophical perspective. Earth is not just where we live, but also a sophisticated machine, a self regulating system with patience stretching over hundreds of millions of years. Human lifespans are but a blink compared to tectonic cycles, yet it is precisely thanks to these slow movements that we have mountains to admire, seas to sail, and land to build civilizations upon. Thinking about this, we can sense the connection between every small tremor and the vast history of the planet. An earthquake is not just a local event, but an echo of forces that have existed since the Earth was still fiery and chaotic. A volcanic eruption is not just an outburst of fury, but a doorway into the primal power still burning within the Earth. Within this instability, Earth sends us a message. Change is not an exception, but its very nature. And it is precisely because of change that this world is never dull, but always reborn in new forms. As you sit quietly listening to this story, imagine the continents beneath your feet not standing still, but shifting little by little. A slow, patient, and beautiful journey beyond the vision of a human lifetime. When we observe the Earth from above, through satellite images or photographs taken by astronauts, this planet appears still and intact. But the deeper we study, the clearer it becomes that beneath that fragile crust lies a colossal machine always in motion. The tectonic plates are not merely moving, they are writing the long story of the entire planet, a story continuously unfolding over billions of years. The wonder is that this motion takes place at many levels at once. On a large scale, vast continents drift at a rate of a few centimeters per year. It may sound small, but in just tens of millions of years, entire oceans can open, new mountain ranges can rise, and the map of the world can change beyond recognition. On a smaller scale, this motion reveals itself through sudden earthquakes, erupting volcanoes, or silent cracks opening on the ocean floor. Imagine the eastern edge of the Pacific, where the Nazca Plate slides beneath the South American plate. This subduction process has ignited the chain of Andean volcanoes with towering peaks like Cotopaxi and Chimborazo, while at the same time shaking the cities below with violent earthquakes. It is a vivid reminder that the relationships between plates are never quiet. They are both creative and destructive, both gifting majestic landscapes and spreading danger. Elsewhere, at the northern edge of India, the massive collision between the Indian plate and the Eurasian plate continues to push rock upward. This very clash has formed the Himalayas, the roof of the world. Think of it. Mount Everest is not an immutable monument, but a living entity, growing higher each year under the power of geology. Even the tallest peak on Earth is just a moment in the endless play of the planet. Meanwhile, along the mid-ocean ridges, creation unfolds in a different way. There, new crust is born as molten lava erupts, cools, and spreads to both sides. Black smokers release superheated, mineral-rich water, creating ecological oases on the seafloor, where life thrives without sunlight. It is a reminder that tectonic movement not only shapes the physical world, but also opens unexpected doors for life. The transformations are not limited to landscapes. Plate tectonics also shape global climate. As continents drift, they alter the paths of ocean currents and monsoons. The rise of the Himalayas, for instance, influenced the Asian monsoon system, affecting the lives of billions. When South America drifted into its present position, it blocked ocean currents, contributing to long-term climate changes worldwide. In other words, the deep shifts of rock beneath can determine the prosperity or decline of civilizations on the surface. Looking further, we see that these silent motions also helped shape evolution. Continents split and reunite, creating isolated or connected regions, opening paths for biodiversity. When the supercontinent Pangaea broke apart, species were divided, evolving along different paths, giving rise to today's richness. In a sense, tectonic movement is the invisible hand that has drawn not only mountains and seas, but also life itself. And it is also from this force that humanity's myths were born. The ancient Greeks believed earthquakes were the wrath of Poseidon. The Japanese saw in the trembling ground the image of giant spirits. These myths, though different, sprang from a common truth. Humans have always felt the mysterious power beneath their feet. Today, science gives us the language to explain these phenomena: tectonic plates, mantle flows, subduction, but the mystery remains. because we are only hearing part of the immense symphony the planet plays. The strange thing is that all these processes happen so slowly that they are nearly invisible within a human lifetime. We live on a moving planet, yet we only notice when disaster strikes, an earthquake, a volcanic eruption, a tsunami. In reality, even when you sit still in the quietest room beneath you, the crust is still shifting millimeter by millimeter, silently reshaping the world. One could say that the beauty of plate tectonics lies in its patience. Mountains do not rise in a night, oceans do not open in a century, but everything is created in rhythms so long they are almost beyond imagination. Science allows us to peer through that veil of time, compressing millions of years into a glimpse, to realize that the world around us is never still. In this silent journey, Earth is not merely the stage, but a main character, a colossal artist patiently carving each detail of the masterpiece we call the living planet. And perhaps the most astonishing thing is not what it has created, but the fact that it is still ongoing, right now, right beneath your feet. When we look at the Mid Atlantic Ridge, we are truly witnessing a tectonic machine at work right before our eyes, though its rhythm is almost unbelievably slow. Molten rock rises from the mantle, cools, and solidifies into new crust, centimeter by centimeter, year by year. This silent rebirth continues without pause, and over millions of years, it opens up an entire vast ocean. Each new layer of rock formed at the ridge's center is like a diary page recording the Earth's movements, preserved in magnetism, in the parallel stripes stretching across the seafloor. These are undeniable physical proofs that this planet has never been still. But the creation of new crust is only half the story. For balance elsewhere on Earth, the old crust must be recycled. At subduction zones, oceanic crust is pulled hundreds of kilometers down into the mantle, where it slowly melts and disappears. This is the planet's basic rule: creation in one place, destruction in another. Without this recycling, Earth's crust would endlessly thicken, and the planet could not sustain its dynamic rhythm. Subduction zones are the sites of fierce dialogue between tectonic plates. When an oceanic plate plunges beneath a continental plate, immense energy is released, producing earthquakes, volcanoes, and sometimes tsunamis. The Pacific Ring of Fire is a prime example, a giant arc encircling the world's largest ocean, where eruptions and earthquakes happen frequently. Millions of people live along these dangerous edges, their lives intertwined with the planet's restless breath. If the mid-ocean ridges are symbols of creation, then subduction zones are the embodiment of destruction, but destruction that is necessary. It is this process that forms spectacular volcanic arcs like the Andes in South America or the Japanese islands. Each volcano is both a testament to immense power and a reminder that our lives depend on the deep cycles within the earth. Beyond creation and destruction, there is deformation, transform boundaries where two plates slide past each other. These faults can remain silent for centuries, but when enough stress builds up, they release energy in an instant, causing devastating earthquakes. The San Andreas Fault in California is a famous example. It reminds us that modern cities, with skyscrapers and highways, are really just fragile leaves drifting atop the planet's giant machine. What is strange is that amid all this chaos, earthquakes, volcanoes, mountains rising, and oceans opening, there exists a remarkable balance. The different plate boundaries seem to coordinate like parts of a cosmic symphony. Each tiny movement, just a few centimeters per year, when accumulated over millions of years, has written the entire history of Earth. Without any part of this cycle, the planet would lose its dynamism, its ability to renew itself. These movements also have a direct impact on life. Fertile soils formed from volcanic ash have nourished human civilization. Mountains shape climate, steering monsoons and rainfall. Expanding and shrinking oceans alter the paths of currents, influencing the entire global climate. In other words, our existence is deeply bound to the hidden forces beneath, invisible to the naked eye. And it is precisely from this motion that Earth has become unique. In the solar system, only our planet has tectonic plates that are this active. Mars, with its vast valleys, once roared with activity, but is now silent. Venus may have experienced global eruptions in the past, but there is no evidence of plate drift like on Earth. This raises a profound question. Could life develop without plate tectonics? Perhaps the crust's rhythm of renewal created a stable enough environment for life to emerge and evolve. Looking back, it is hard to believe that the idea of drifting continents was once mocked as absurd. But that is how the history of science works. What seems outrageous today may become tomorrow's truth. Earth keeps teaching us that truth hides in silence and in time, waiting until we are ready to see it. The jigsaw puzzle of this planet has never been complete. The plates continue to shift, opening new oceans, raising new mountains, and erasing old horizons. Each human generation witnesses only a fleeting moment in this billion-year symphony. And as we stand on ground that feels solid, we must remember, beneath our feet, Earth is still breathing, still moving, still writing its never-ending story. If the expansion of the ocean floor brings about the birth of new crust, then subduction is the other arm in the planet's balancing dance. Earth does not endlessly accumulate material on its surface. Instead, it continuously recycles, like an artist who both creates and erases to begin again on the same canvas. The process of subduction shapes magnificent landscapes, but at the same time sows immeasurable danger. When two tectonic plates meet, the heavier, colder, and denser oceanic crust almost always loses, sliding beneath the lighter continental plate. This movement does not unfold peacefully. It leaves behind violent marks, from massive earthquakes to fiery chains of volcanoes along continental edges. Imagine a deep ocean trench. It is not merely a random crack, but a geological wound stretching thousands of kilometers, where the crust is pulled into the dark abyss. The Mariana Trench, deeper than Mount Everest is tall if inverted, is the clearest testament to the power of subduction. In that dense darkness, pressure is so immense that metal would deform like soft wax. And on the surface, along Japan, Chile, or Alaska, human communities still live right at the edge of this instability, where the ground can tremble violently in an instant. The colossal tsunamis that have swept away cities and redrawn coastlines are only the outward consequences of this hidden process. But subduction does not only bring destruction, it is also the source of creation. When the oceanic crust sinks into the mantle, it is not simply crushed, it carries with it water, gases, and minerals. These components lower the melting point of mantle rock, allowing magma to form. Streams of glowing red lava rise through cracks, accumulating into volcanic mountain ranges. The Great Andes in South America, stretching thousands of kilometers, is the product of this process. In North America, the Cascade Range, with volcanoes like Mount St. Helens, also came to life through subduction. And across the Pacific Arc, volcanic chains from Indonesia to Japan are vivid evidence. This is Earth's beautiful paradox. Destruction in one place nurtures creation in another. On the scale of time, subduction is the planet's recycling engine. Young oceanic plates are born at mid-ocean ridges, then slowly drift away. After hundreds of millions of years, as they cool and grow heavier, they become candidates for subduction. A life cycle ends in fire, but from it, new cycles begin. Without this process, the seafloor would only expand endlessly, pushing continents ever farther apart, and Earth would become an unbalanced planet. Instead, thanks to subduction, a dynamic yet enduring state is maintained. Continents collide, split apart, and reunite. Seas open and close, the cycle repeats like the planet's slow, steady breath. What is astonishing is that even the mighty mountain ranges on land bear the marks of past subduction. Granite masses, the ancient Himalayas or Alps, were once the sites of vanished oceans. Layers of basalt, once seafloor, are now found atop mountains thousands of meters high. This is proof that entire oceans can be swallowed, uplifted into continents, then eroded over time. Earth, quite literally, has rewritten its own map many times. The influence of subduction reaches even into the atmosphere. When magma erupts from volcanoes, it releases greenhouse gases like CO2 and water vapor, along with sulfur gases that can cool the climate in the short term. On the scale of millions of years, these eruptions have helped regulate Earth's temperature, sometimes triggering ice ages, sometimes opening warmer periods. A volcanic arc not only shapes landscapes, it also contributes to the global climate's rhythm. Yet many mysteries still surround subduction. Scientists continue to debate how the process begins. Does a plate simply grow too heavy and collapse into the mantle, or does it require an initial push, a major geological event, to start it? And why do some subduction zones operate for hundreds of millions of years while others remain inactive? These questions remind us that Earth never fully reveals its secrets, but perhaps the most captivating aspect lies in the scale of time. A tectonic plate takes hundreds of millions of years to complete its life cycle, from birth at a mid-ocean ridge to being subducted and melted. During that span, species may appear, evolve, and go extinct. Whole civilizations are but a blink of an eye. To us, an earthquake or volcanic eruption is a catastrophe, but to Earth, it is merely a familiar beat in its endless cycle. Looking at subduction, we realize Earth is an extraordinary regenerative system. It never allows itself to grow stagnant or stuck. It recycles rock, nourishes volcanoes, raises continents, opens new oceans. Thanks to this, the planet has remained vibrant for over 4 billion years. Without this process, Earth might only be a dead world, like the Moon or Mars, where the crust lies motionless for billions of years without renewal. Subduction, therefore, is not merely a geological mechanism. It is a deep pulse, ensuring that our planet always changes, always regenerates, always prepares new settings for life. Hidden deep within the Earth, amid crushing pressure and searing heat, the planet is writing its own story, a story without end, where destruction and creation intertwine in a slow yet eternal dance. When the ground shakes, we realize that the peace beneath our feet has only ever been temporary. An earthquake is not an isolated phenomenon, but the result of centuries, even millennia, of pressure building up between tectonic plates. Each time two plates slide past, collide, or overlap, energy is silently stored, waiting for the moment when nothing can hold it back, and then it erupts. In an instant, the crust, like a bowstring pulled too tight, snaps and releases, sending ripples of energy coursing through the earth, making cities, forests, and oceans tremble in humanity's helplessness. What makes earthquakes so frightening is their absolute unpredictability. Volcanoes can rumble warnings, storms can be tracked by radar from afar, but earthquakes often strike at the moment we are most unprepared. A peaceful morning can turn into disaster in mere seconds. Cracks gape open, buildings collapse, and the ground, the very thing we trust the most, becomes the threat. Major earthquakes not only reshape landscapes, they can generate tsunamis, alter river courses, and even raise entire regions by meters within minutes of shaking. Yet beneath the destruction, earthquakes are also reminders that this planet is alive. Unlike Mars or the Moon, where the crust has cooled and fallen silent, Earth is still in constant motion. It is this movement that keeps the crust renewed, the landscape ever-changing, and even helps sustain life. Without Earth's restlessness, there might be no mountains to gather rainfall into rivers, no new continents for life to flourish upon. Earthquakes, in a deeper sense, are expressions of a planet's living system. Scientists study earthquakes by listening to Earth. Seismic stations scattered across the globe act like giant ears, recording even the faintest tremors. From these signals, they map hidden faults, estimate levels of risk, and identify vulnerable regions. Although predicting exact earthquakes is still impossible, science has given us a clearer understanding of the mechanisms and better preparation to reduce damage. Earthquake-resistant buildings, tsunami warning systems, and construction codes have all emerged from this difficult learning process. Each earthquake leaves not only scars, but also lessons for humanity to adapt. Consider the energy an earthquake releases. A magnitude 8 quake on the Richter scale can unleash the power of hundreds of nuclear bombs exploding at once. And yet that is still only the reaction of a thin slice of the planet's crust. This fact is awe-inspiring, a testament to Earth's hidden strength. And it is this same energy, released steadily over millions of years, that has built mountains, widened oceans, and reshaped continents. Earthquakes, ultimately, are not only disasters, they are the heartbeat of the planet. The places that shake the most are often the very places humans choose to call home. The Pacific Ring of Fire, where subduction zones and faults converge, is home to hundreds of millions of people. Japan, Chile, Indonesia, all are familiar with restless ground. Instead of fleeing, people learn to coexist. Culture, architecture, and even national character in these regions bear the imprint of adapting to instability. The Japanese developed the art of building structures that sway with the earth without falling. Chileans established strict codes so that cities could withstand tremors that would devastate other places. In adversity, human resilience shines. But it is not only humans who are affected. Ecosystems, too, respond to earthquakes. A major fault shift can create new lakes, redirect rivers, or open entirely new habitats for species. Fertile valleys, lush forests, and unique wetlands have been born from geological upheaval. From another perspective, earthquakes contribute to Earth's biodiversity. Of course, living with earthquakes is a double edged sword. They can destroy cities in an instant, but it is thanks to them that the planet never ceases to renew itself. The challenge for humanity is to enjoy the gifts of a dynamic Earth while minimizing the risks of unavoidable tremors. This requires knowledge, technology, and above all, humility before nature's power. Looking back, earthquakes teach us a profound lesson about fragility and resilience. Fragility, because even the strongest structures can collapse within seconds, but resilience, because humanity continues to build, continues to live, and continues to seek harmony with a planet in motion. In a way, earthquakes reflect humanity's own journey. Each shock, each collapse, opens the chance to rise again and rebuild. And when the tremors subside, when the ground grows still, another kind of silence settles. In that moment, we can hear more clearly the whispers of Earth, not as threats, but as reminders. This planet never stands still. Life, mountains, oceans, all exist because of this ceaseless motion. When a volcano awakens, it is not just a geological event, it is a performance of the Earth, both destructive and creative. A major eruption can darken the sky for months, turn day into night, and cover the ground with a layer of ash so thick that trees break and roofs collapse under its weight. Yet, along with that destruction comes a new beginning. Those tiny dust particles, when they settle, carry minerals that enrich the soil, preparing it for a new generation of life to flourish. This is the paradox of volcanoes. They destroy just before sowing the seeds of prosperity. Looking deeper, volcanoes are also unique windows into the inner world of the planet. Each eruption brings to the surface fragments from the deep mantle, minerals that reveal secrets about the composition and movements below. From these studies, scientists came to understand that Earth is not a solid, motionless mass, but a complex circulating system with convecting mantle, mobile crust, and a fiery core providing energy. Volcanoes, in a way, are the voice of the planet, allowing us to hear the heartbeat from within. Perhaps nowhere demonstrates the role of volcanoes in shaping living environments more clearly than Iceland. This island is a child of fire and ice, formed by lava flows erupting from the mid-Atlantic ridge, yet carved and covered by glaciers. Here, we see contrast but also balance, new lava creating land, while glaciers erode and reshape the landscape. The people of Iceland, instead of fearing, have learned to harness. They tap geothermal heat from the earth to warm their homes, cook food, and generate clean electricity. As a result, Iceland has become one of the nations most dependent on renewable energy, a testament that even Earth's fury can be transformed into human benefit. Yet volcanoes are not always so generous. Super eruptions of the past reveal power far beyond imagination. About 74,000 years ago, Mount Toba in Indonesia exploded, releasing such a vast amount of ash and gas that it nearly blanketed the globe. Many scientists believe the climatic aftermath of that event nearly drove humanity to extinction, leaving only small groups of survivors. This shows the direct link between geological activity and the fate of life on Earth. One eruption can affect not just a region, but alter the planet's climate for decades. Sulfur dioxide from volcanoes, when reaching the stratosphere, reacts to form tiny droplets of sulfuric acid. These reflect sunlight back into space, lowering global temperatures. On the other hand, carbon dioxide contributes to warming the Earth. These opposing effects make volcanoes one of the natural regulators of climate throughout geological history. One eruption can bring a freezing volcanic winter, yet also add greenhouse gases in the long term, helping keep the planet warm enough for life to continue. It is undeniable that humans have been fascinated by volcanoes since ancient times. Early civilizations often saw them as dwellings of gods, symbols of power beyond understanding. The Greeks linked Mount Etna with the forge of Hephaestus. The Polynesians had Pele, the goddess of fire, believed to reside in the heart of Kilauea. Today, even though science has explained much of their mechanism, that awe remains. Standing before a smoking volcano, it is hard not to feel small and humble before its scale. However, from a broader perspective, volcanoes are among the most important planet builders. Without volcanoes, there would be no air like the one we breathe. It was ancient eruptions that released water vapor, carbon dioxide, and nitrogen, creating the primordial atmosphere. From that vapor, rain fell, gradually forming oceans. One could say that the life we know today originated directly from those ancient plumes of smoke and flows of lava. In modern times, volcanoes have also become natural laboratories. Scientists study how microorganisms survive in the extreme heat and acidity around hot springs and vents. These extremophiles not only expand our understanding of life on Earth, but also suggest the possibility of life on other planets and moons, such as Jupiter's Europa or Saturn's Enceladus, where ice volcanoes may exist beneath hidden oceans. Thus, learning about volcanoes not only deepens our knowledge of Earth, but also opens doors to exploring the universe. Nevertheless, volcanoes always remind us of the limits of human control. We can somewhat predict them, we can evacuate when necessary, but we cannot stop lava or ash once an eruption begins. Instead of resisting, we learn to adapt, building warning systems, preparing response plans, and most importantly, respecting natural laws. Volcanoes are not just destroyers or architects, they are both, simultaneously and inseparably. They bring fear, but also sow life. They destroy, but also renew. They remind us that Earth is never still, and it is thanks to that restlessness that this planet became a fertile home for life. And so, when we stand at the edge of a crater looking down into the depths where lavas, what we feel is not only fear, it is also admiration. Admiration for a planet that is alive, that is creating, and that is telling its story in its most primal language, fire. When we listen to the silent heartbeat of the Earth, it is easy to mistake this planet for a motionless, safe, and quiet block of rock beneath our feet. But the truth is the complete opposite. Beneath the green fields, the bustling cities, or the vast oceans, Earth is a giant machine that never stops working. Heat from the inner core and mantle constantly drives the movement of tectonic plates, like enormous pieces drifting across an ocean of magma. And it is precisely these slow yet powerful motions that have shaped the surface we know, from the towering Himalayas to the deep Mariana Trench. Looking out to the oceans, which cover more than 70% of the planet's surface, we realize that most of Earth still lies beyond human understanding. The seafloor is not a gentle plain, but a vibrant geological canvas, where mountains, fissures, hydrothermal vents, and deep trenches intertwine like colossal strokes. Every detail reflects the endless rhythm of plate tectonics. When plates separate, magma rises and forms new crust. When they collide, the old crust is pushed deep down, sinking into the mantle, only to be reborn elsewhere. This is the grand cycle, both destructive and creative, and it is also the foundation of life. One of the most magnificent proofs of this rhythm is the mid-ocean ridge, the longest mountain system on Earth, stretching over 60,000 kilometers. If all the ocean water disappeared, these ranges would far surpass the Himalayas in grandeur, becoming the backbone of the planet. Here, lava flows out in the darkness, slowly cooling and expanding the oceanic crust. It is hard to believe that such majestic landscapes are quietly unfolding beneath the deep waters, thousands of meters away, where sunlight never reaches. It is precisely in that darkness that scientists discovered communities of organisms that do not depend on sunlight. Around hydrothermal vents, giant tube worms, white crabs, and enormous clams thrive, living on a completely different energy source, chemosynthesis, where bacteria use chemical reactions with minerals to produce energy. This discovery not only transformed our understanding of biology, but also inspired new hypotheses about the origin of life. Perhaps it was in such extreme environments that early life found safe refuge from the chaotic surface of Earth billions of years ago. But the journey into the deep ocean brings not only stories of life, but also geological memories of Earth. When new crust forms and then cools, iron-bearing minerals in the lava align with Earth's magnetic field. Over millions of years, as the poles reversed, opposing magnetic stripes were etched like strange patterns onto the seafloor. These magnetic stripes became compelling evidence for plate tectonics, showing that the oceans are truly expanding and that our planet is anything but still. Beyond that, the sediments settling on the seafloor act like ancient journals. Microscopic particles fall from the ocean's surface, accumulating layer by layer over time, preserving traces of climate, chemistry, and ancient life. By drilling deep into these sediments, scientists can reconstruct climate history spanning tens of millions of years, uncovering evidence of ice ages, extreme warm periods, and even mass extinctions that once shaped life. Yet, what makes the seafloor so captivating is not only its role in the past, but also the mysteries left unsolved. Only a small portion of the ocean floor has been explored in detail. Vast regions remain untouched by humans. Each expedition into the depths brings surprises: a strange species, an unimaginable landscape, or a newly discovered underwater volcano. The feeling is like stepping onto an alien planet, though everything lies just beneath our feet. This also presents a humbling truth. The Earth we know is only the surface. What lies beneath the oceans, beneath the crust, or deep within the mantle remains secrets yet to be unraveled. Volcanoes, deep trenches, ridges, and hydrothermal vents are not just geological features, they are gateways, revealing glimpses into the workings of the immense machine called Earth. And when we connect all these pieces, from erupting volcanoes in Asia to the underwater ridges of the Pacific, from the deepest trenches to ancient sediments, we see a truth. This planet has never stood still and never will. It is always changing, always renewing, always challenging human understanding. Earth is living proof that instability is not merely a threat, but the source of beauty, of life, and of our very existence. Each time we listen to stories from the ocean's depths or the breath of a volcano, we are reminded that we are only a small part of this vast and eternal rhythm.